It really is my pleasure to be here today. We've heard from some phenomenal companies who are doing some amazing things, who, for me, really epitomize the next wave of technology. As we stand here, we're at the cusp of a new generation of technologies which are going to fundamentally change the world. And it is fantastic for me and for ARM to be part of this family that is going to create all of this change and all of these disruptive technologies you've heard about. At ARM, I think we understand disruptive technology shifts because we've played such a major part of the last major disruptive technology shift, that of the growth of mobile. From the very first digital cell phones through smartphones, it has been ARM processing technology that has delivered more and more compute power in your pocket generation after generation. And when we think about the information revolution ahead of us, it's a fantastic thing for our business because it's going to need computing on a scale that we have never seen before. Vast amounts of computers distributed into anything and everything. ARM is part of a partnership. We license technology to semiconductor companies who build chips. And collectively, our partners have shipped over 100 billion chips containing ARM technology. 100 billion chips is a phenomenal number. Very few things are built in that kind of quantity, but we're only just starting. That first 100 billion chips took 25 years, and we think the next 100 billion will only take 4 years. And the reason for that is because of all of the technologies that you've heard about this morning. So you may think that that is why Massa acquired ARM, why he paid so much, which has been widely reported, to acquire the company. But ARM is more than that. We're more than just a company creating technology. We're a vast partnership. We're an ecosystem. And that is what SoftBank have bought into as part of ARM. We count every major technology company as our partner. And that ecosystem, that partnership, is shipping chips at a rate of 600 per second. In the time I've been speaking, thousands, tens of thousands of chips have been deployed by this ecosystem into all sorts of technologies. And as I said, I think we're only just getting going now. So at ARM, we've always had a very large ambition. We've always wanted to create this global standard from our outset nearly 27 years ago. But now as part of SoftBank, we can think even bigger. So we're thinking about this next wave of technology. And this next wave, as is obvious, is going to be built upon data. Gathering that data, transmitting that data, processing that data, all relies on computing. Computers which can be big, computers can be small. Our first ARM processors, the very first ARM1, was about the size of a shirt button. Didn't have much processing power. It sat in a very simple desktop computer at the time. Today, that has changed. We can deliver thousands of times more compute power in basically the size of a pinhead. A processor that can be so small you can't see it. And what's revolutionary about that is that it means it can be deployed into anything, and it can be deployed at very, very low cost. And that is going to create a fundamental change in the way that we gather and process data. So I think this is a catalyst for innovation and enables almost limitless potential. Now, one of the benefits of our partnership is being able to talk to lots of people about what's going on. We've always viewed that we don't have the answers to everything. We like talking to people about their views. So to think about where these technologies could be used, we decided to go and interview some futurologists, some people thinking about the future. And I have a short video here to explain to you what they said. So let's play the video, please.
I think that imagination is just your vision of things that could be.
Oh, imagination means, anything can happen if you want it.
You can think of something, and you can kind of like build it out in your mind, and then you can try it. If it works, then it can like possibly be a big thing and help like people's lives.
Everything would have a specific teleportation address, and maybe you would have like an armband where you input the teleportation address, and then it would turn you into data, send you up to the cloud, deliver you to where you want to go, and output you as you.
I think if my house could paint itself every day, I would tell it to paint itself a different color, matching the mood of that day.
When you like think about what you want to say, then it'll just write it down for you. Like if you were thinking of like an image or something, like it would just be there.
Some scientist could make something that you strap to your head and projects your dream.
I think things in the future could have feelings.
The cans of food that you're gonna have makes it and like cooks it by itself.
If you're going somewhere and you're not supposed to go, the robot's arm will get you.
You could cloud hop.
No, I think if we look at it like from different angles, all we can do is just, have that light bulb and, help you invent something, because like anything is possible if you really, really, really try.
So some amazing ideas from the next generation of technologists, the next generation of consumers, the next generation of people who are going to invent the next generation of technology. I really like some of the things that came out of that. Whether the world exactly pans out in that way, who knows? Whether their predictions are exactly correct, who knows? But I am sure it's going to be really, really exciting as we put all of these technologies into their hands and they can come up with all the things that we couldn't possibly think of. Now, one thing I truly believe about this next wave of technology is that it's going to enhance human capability. I see the future of the world where technology is being used to make people's lives better and to enable people to do things that they can't currently do today. If we take surgery, the picture shown here maybe looks a little bit scary. We have a doctor using a surgical robot. This is the Da Vinci robot. And while we may hear about robots putting people out of work, here the robot is enhancing the capability of the doctor. It's an expensive piece of machinery, but it leads to better results, better outcomes, faster recovery times, fewer issues in the surgical theatre. It leads to a better result. And it's just one example of how technology and data is being used in the medical setting. Now, I haven't ever had surgery, fortunately, but if and when I do, I want to be hooked up to something like this because I'm more likely to get a better result through this use of technology. It's just one example. Computers are being used to analyze chest X-ray images, look for data that humans find it really, really hard to spot. There's an analogy that says computers are really good at things that humans are bad at. So if we put these two together, we can enhance human capability. Now, here's another example from the medical world, and this is where virtual reality is being used to enhance the training of doctors. If you go through medical training, you have to learn what it's like to be in an emergency room. The way that's done today is very, very basic. There's a bunch of people standing around with clipboards. There's a mannequin that just lays there. What this company, BioFlight VR, have done is try and apply thinking from flight simulators, technology that's used to train pilots, and take that to train doctors. So here they can set up virtual worlds, an environment that really does look like an emergency room. They can run many, many different scenarios. They can analyze the way the trainee doctor performed, provide feedback, and just provide a mass of more training. Again, if you're ever in an emergency room, I want to hope that the doctor's as trained as possible, and this technology can help achieve that. So the medical industry is going to be a huge beneficiary of the technologies that we've been talking about this morning. It's going to keep us healthier, it's going to keep us fitter, life expectancy is improving all the time. But as you heard earlier, humans do something on a daily basis which is incredibly dangerous, and that is driving cars. I recently saw a presentation on some data from the US which said that in 2015, 35,000 people died on the roads of the United States. 35,000 people, that is a lot. Driving in Japan is a lot safer. There's only about 4,000 people who sadly die each year. A lot safer, but it's still 4,000 people who needn't lose their lives in traffic accidents. What's staggering from that 35,000 road deaths in the US is that only a tiny proportion came from mechanical error in the car. Some 96% was caused through human error. Distracted drivers, we heard about that earlier. Events happening that the human just can't respond to quickly enough. And the good news is that technology can solve that. Technology is already making driving much safer. Airbags, anti-lock brake systems, basic seat belts, lane avoidance systems, they are making cars safer all the time. But when we get to fully autonomous driving, then we have the potential to get those number of road deaths down to 0. We've got a long way to go, though. The technology that's in self-driving cars today is impressive, but it's got a long way before it can truly handle every scenario that a car would ever see. So much progress is being made. The technology that's in self-driving cars today, it's great. It's consuming quite a lot of energy. The systems you see today consume about 3% of the battery of a self-driving car, of an electric vehicle. And you may not think that's much. You may think, well, the battery in an electric vehicle is huge. It's about 2,000 times more powerful than that of your smartphone, so 3%, who cares? The problem is that the technology in self-driving cars that we have today is just the starting point. To truly deliver level 5 autonomy, where a car can deal with any situation that's put in front of it, situations it won't have been trained to see, situations it will just react to, that requires orders of magnitude more computing power in the car. It requires that computing power to be backed up with the learning from millions and millions of miles driven by lots of cars. It just requires a huge amount of more computing technology, and that, unless we do something, will consume way too much power to make it viable. Your car will become a supercomputer on wheels. But what we've got to do from a technology perspective is get the energy consumption down. We've got to get the cost down to make fully autonomous electric vehicles financially and technically viable. Now, again, good news. I believe we can do this. There's some science to do, but it's largely an engineering problem. So we can do that. Technology is going to make our lives safer generally. We're going to put cameras, we're going to put computers everywhere to make our lives safer. When we take public spaces, you look at in any developed country around the world, we're seeing many security cameras starting to appear because sadly there are bad people in the world who want to do bad things, and of course we want to avoid that. Problem is, with a regular security camera, we're generating too much video feed than anyone could ever possibly analyze, and that's where computers come in. At ARM and many other companies, we're working on technology to enable cameras to be intelligent at the point at which they're filming a particular scene. What we're showing here is the analysis of a scene, looking at what people are doing, trying to spot any gestures, any behavior that's unusual, and then, if necessary, go and call for some backup. So smart cameras, intelligent cameras, are going to help keep us safer. What they will need, what the cars will need, what pretty much all modern technology is going to need is continual evolution in the networks that connect devices together. And I don't just mean more speed, more bandwidth, but an actual creation of intelligence through the network itself. Traditionally, networks basically connected a device to a data center over what is a sophisticated switch, but in the future that's going to give way to intelligence through the network. Give way to what we at ARM call the intelligent flexible cloud, where processing is done on data as it is moved around. Processing is done at the most appropriate point for the data. The world won't get the benefits of all technology if every piece of data is sensed at the endpoint, all taken to the cloud, analyzed, and then a result given back. There just isn't enough time and there isn't enough power to do that for the kind of scale that we want to deploy. So the network is going to have to become a lot more intelligent. And we have to do this. There's some great data out there showing just how much data, and you've heard it today, how much data is being produced. Google are pioneers in voice recognition technology. They've done some analysis recently that said if every person with an Android phone spent 3 minutes doing voice recognition, speaking to their phone, they would have to double the number of data centers that they have. Now, clearly, that's a very expensive, very power-hungry proposition. So we have to make intelligence deployed to the place where it is best needed, deployed where the data is gathered, data getting thrown away if it's not necessary, and information making its way up the stack into the cloud where it can be coupled with information from many other sources. So we have to keep evolving the intelligence in all of these devices. The device itself, the endpoint, the network, and the cloud. All of this has to be enhanced. So I've talked about a few examples of the benefits of distributed intelligence, this concept of just getting computing out there, gathering data, and processing it along the way. Making that happen is going to require a global ecosystem. We can't do it on our own, you can't do it on our own. We're going to have to work together in partnership to deploy all of the technology and all of the intelligence to deliver on our future dreams. At Arm, we think we're best placed to play a key role in this ecosystem that's going to deliver all of this technology, because we've spent the last nearly 27 years building this global ecosystem of partners. Whether it's people building chips, people writing the software to run on the chip, people building the device that the chip goes into, people building the cloud technology that the data and the information ultimately ends up at. We have this huge partnership of companies who are looking to push the bleeding edge of technology every single day. We're going to do that with a focus around efficiency, getting power down, getting costs down, so that everyone can benefit from the technology on a global basis. And we're also going to do that with a laser focus on security. None of the examples of the technology you've heard today will be delivered unless the technology can be trusted. And to do that, we have to do a lot of work to make sure data is encrypted, that systems cannot be hacked into, that intrusions are detected, and that the software is updated, the systems are updated whenever some new threat appears. That is what we're doing, that is what we are doing within our partnership. So ahead of us lies an enormous technology shift. This distributed intelligence, these tiny computers, these big computers, are going to be the foundation of the information revolution. And it's going to lead to a safer, more sustainable world of opportunity. All of those advances in computing are going to lead us to this point of singularity that NASA is focused on. And that, to many people, is a pretty scary proposition. Many people fear the impact that that's going to have on the world and on jobs. But I believe that this next wave leads to greater quantity and greater quality of life, and that's going to be a benefit for everyone. A lot gets written about this from many different places, people taking many different views. I particularly like this quote, and this is from Garry Kasparov. It's a name who's very well known. Garry Kasparov was the world chess champion for many, many years, and he ultimately got beaten by a computer in 1997. IBM spent a lot of time, money, and effort building a computer to beat the world's best chess player at the time, and eventually they did. Now, you would think that Garry Kasparov would be a little bit bitter about that and kind of resent being put out of work by a computer, but he's actually pretty balanced on it all. And this quote that worrying about this is the wrong thing to be focused on, I think is absolutely the key point. Grave digging is not a large source of employment today. I'm not worrying about my children choosing that as a career. I'm not worrying about them becoming chimney sweeps or putting shoes on horses. I'm thinking about the jobs that are going to be created. There are many new types of job being created all the time. In Silicon Valley, if you want to hire a data scientist, good luck to you, because there aren't enough to go around. It's an example of the kind of job that's been created through these technology shifts. So I believe we are just getting started. It is a really exciting era for the technology industry, and as a result, that's going to benefit every single person on this planet. As part of the SoftBank group now within Arm, it's a really exciting era for us as well. It's almost a year ago to the day that we announced the acquisition, a day that is etched on my mind forever. And it's really fun to be part of this group and work with such phenomenal companies. So together, we're going to use this next 100 billion chips to create a world that's worthy of those dreams and aspirations of the children that you saw in the video earlier. I think this future is amazing, and I can't wait to deliver it. Thank you very much.